This is a video for anybody who's interested in knowing more about how the Markov chain project all comes together. I'm going to go through the slides super quickly, and I'm going to, stop off and make a point of any of the slides that are very specific to this project, which the girls might not have done before. I'll also live code the whole workbook, and then you can see how all the code comes together over the course of the day. I'll be working through beginners and intermediate. The way these two projects fit together is all the beginner and intermediate girls start off with the beginner workbook, and then that part is about generating text, so we'll be providing a dictionary, so they get to do the fun part, generating crazy sentences first, and then anybody who finishes that, which will be mostly intermediate girls, will also get to do the second workbook, which will be about creating their own dictionaries from whatever text that they like. So yeah, let's get started. I'll show you firstly where all these workbooks are going to be. They're going to be on our website for the day, and we've got two sections here, workbook 1 and workbook 2. We're going to be starting off with workbook 1, which is the beginner's workbook. So the girls will have access to this site as well. They'll have printouts of the workbook, but they'll have access to the slides as well if they need to, go back and check something out. So yep, that workbook link will take us to this workbook here, the beginner's workbook. And sneakily, you can tell the difference between the intermediate and beginner's workbook by these little pictures here. The little girl is for beginners, and then the intermediate workbook will have a computer on it, which will be fixed soon. So let's get started with our beginner's workbook. Firstly, with the beginner's room, we're all going to start with introduction to programming, because a lot of the girls will have never done programming before. So we're going to start off with some concepts on that. So this is the lecture number 1, Intro to Programming and Intro to Python as well. So we're basically going through telling them what programming is all about. It's about giving instructions. I should also note I've got the speaker notes off to the side. Anybody who is doing a lecture, you'll be able to go through these, and you can see the speaker notes come up here. So yeah, watch out. If you're doing a lecture, you can go check out your speaker notes beforehand and on the day. So yeah, we are talking about what programming is. It's just about giving instructions to computers. We have a special language to do it in because computers are really dumb and they need a lot of help in learning what humans want them to do. We need to give them very clear instructions. They need to be in a very specific order. It's a lot like cooking. We do things in the wrong order, things get a bit crazy, and we don't end up with what we want. The computer isn't smart enough to figure out that the instructions are wrong, so we just end up with a mess instead. We're telling them about what programming is about, where computers come into it and where humans come into it, and how humans are actually the brains behind everything. Computers are actually not that smart. So then we get to the actual coding part of the day. We're opening up idle, which I've got open here. You can just get them to press like the Windows key on the computer and type in idle and get them to open up one of the 3 whatever idles that are available. The first thing of the day we are getting them to do is make a big error, because errors are scary, but so let's get that out of the way early in the day. I'm going to hit that. It looks crazy. A big red error message. That's a bit scary. But that's okay, because errors are actually here to help people find mistakes. Errors were invented by humans. They're not just a way of the computer being angry at you. They're just there to help the programmers. So we've done the hard part of the day. We've made an error and it's been okay. Now we'll be able to learn how to read errors later in the day. The next part is, of course, Hello World. If you're doing a lecture, feel free to live code any of these as well. Get the girls to do all the parts that say, give this a try. Then we're just doing some basic maths. I won't do them all for you, so you can just try it out in the interpreter. These are all in the interpreter one. We're not getting up to files, storing our code yet. And then you can click through these. Yay, we did maths. That's really cool. Then we are working with strings and doing crazy, maths with strings and adding them together, which is cool and new and exciting, a really cool kind of calculator. This is just to explain that strings are different to numbers. They're basically just like pictures. Words are just a sequence of letters and squiggles that are essentially pictures to Python. Then we get into these fun ones where we get to see the difference between strings and numbers in action, which is pretty cool. Now finally we get to tell them about variables, our first big concept of the day. Variables, we need them for storing things, especially things that we want to change because they're going to make our code much easier to write and change later. So you might want to store our number in a box called favorite number. Essentially, we're just putting a label on a number we want to use later. Might want to use that number several times later. So we've stored our favorite number in this box. But it seems a bit silly. We could have just written 8 minus 6, 8 plus 21. So it's a bit crazy to write fav numbers, which is actually really long. So we see the actual beauty of variables is when we want to change something. So if we've now put 102 into favnum, we can see that we can just use the exact same code to compute our new favorite number mathematical, operators and puzzles. And we can see that we have a lot less changes if we've used a variable. So then we just get them to have a play around again with the different, maths and things. Now that they know how to do variables, they can store some numbers and do some more calculated things with it. And then we have printing again, so we can put numbers and words together, and we can use print our function with with our variables. So we also have what happens when we make a copy of something. X equals 3, y equals x, x equals 5. We've changed to x, what's going to happen to y? Y is still 3 because we've made a copy of it. And now you're getting up to the fun part, which is input, which will be important for our project because we're taking input as the seed for our random text generator later. So we'll be getting them to copy this code in, and then they can, the computer will ask them a question, and then they can print out the answer. That's just another puzzle for them to do. The idea of the lectures is we teach them a bit about a concept, we get them to do it, and then we get them to transfer the knowledge shortly into their project. So transferable skills, yay. Now we're opening up a file. Here's one I prepared earlier. We can run that with pressing F5, and it's great. Now we have a code we can run a bunch of times. We can go through and we can add a comment to our file. And we can run it again and see that nothing changes. Yay, good. The real important part of this section is we want to learn how to do print with and changing what the end looks like, because for our Markov chain generator, we're going to be printing one word at a time, but we don't want them all on different lines because that'd be a really long piece of text. So we're going to use end to get rid of the new line that is automatically there as the default and replace it with a space instead. So we're going to do that here. So we've got rid of this, and we've got print, world. That would give us this. We don't want that, so we're going to do end equals space here. Hooray, good. Now we're up to doing the project, hooray. So we're going to need to get our workbook out, which is this workbook. Okay, we're starting by opening a new Python file. And I'm going to call mine Markov Chain 5. Okay, cool. We have now done that. We're going to add a comment. Markov. Yeah. Okay, cool. Now, we're making sure the kids tick these off. They have a habit of skipping through parts of the workbook just because they get distracted. So now we have these cool red check boxes for ticking things off. We're going to print a welcome message. Yay. We're going to make sure we run the code because otherwise they just forget to do that. And they get to check off more boxes. Hooray, achievements. Okay, excellent. Now we're up to input. now we get to ask a question. We want to store it in current word, and we want to find out what word the user wants to start their Markov chain with. Current word input, and the question is, what word do you want to start with? Move that up. Okay. Okay, cool. And then we want to print current word on the next line. Awesome. We can do that, and we can run that, and we can see if we'll ask a question. I want to start with A, and it prints out A. Yay! Check off those boxes. Winning, already up to part 3. And it's time, we can see here by the little blue arrow, for another lecture. This lecture is on dictionary. So if you're doing the dictionaries and lists lecture, your lecture is actually split into 2 parts. If you're in beginner's classroom, you probably only get to the first half, unless some girls get through the whole of the first workbook. But for the first part, we only need to be accessing things in the dictionary we're going to provide. So we're not setting any variable, setting any keys and values in the dictionary. We're just accessing them. So we're using shopping as an analogy. We don't like storing pieces of information by themselves when they should be all kept together. So we don't keep things in a bunch of variables. We keep them in one big list. It's much more convenient. We can see they have square brackets and they are separated by commas. And basically we're just getting them to play around with some lists. We're giving them a shopping list to copy in. Then they are accessing different items in it, seeing what it prints out, seeing that thing is indexed from 0, working out how to get this item here at the end of the list, and then playing with the pen, which is something that the intermediate kids will need to do later, and just something to keep them occupied. Then we're already on to dictionaries, and we are using the analogy of an actual dictionary, of course, because they understand what that is. And we can see that you can look up something and you get back a matching piece of information. And there's lots of different kinds of things, pieces of information we might use this for, like a phone book or a vending machine, or for a list of people in a team, which is useful because we'll be using lists later inside our dictionary. We can see that they all have a thing you're looking it up by, the key, and the value you get back when you look it up. And we can see how we assemble a dictionary. There are pairs of information separated by commas between the pairs, and each pair has a key and a value separated by a colon. And we assign it to a variable. Then we're playing here around with dictionaries here, working out how to get the corresponding values for Alex. How would we get Emma's phone number? And seeing what happens if we look something up that's not in the dictionary, and exploring the fun that is the key error. Playing around with storing the value that you look up in a variable and then using it later. You can also, we're going to play with using lists inside the dictionaries, because this is what we're going to need for using the dictionary we're going to provide for the Markov chain generator. So we can see we've got a key and a corresponding list. And what we want to be able to do is add to the list for fun, or be able to get back, the whole team here if we look up this key to Sydney Seagulls. And then we'll need to store that later in a variable when we are doing it in the project. But we didn't want to give it all away here. So how this relates. So at the start of the day, we're going to be doing an activity called the cups activity, and we're actually going to be doing a Markov chain generator based on using cups. So we're going to prepare cups that will have on the outside a word, and inside the cup will be lots of pieces of paper that have all the words that could have possibly followed that in a text. So we'll be using green eggs and ham. So there'll be a cup that says Sam, and then in the cup there'll be pieces of paper that say things like I that come after Sam. And so the kids will get to see how Markov chain generator works in real life, and then we're going to do that with programming. So we can see that the key on the outside of the cup is the value, is the A, and then the values are all the things inside the cup. So we've got a list of values, effectively. So here's how we would actually store it in a list in Python, and we can see this key A goes and refers to this list. So now we're giving them a dictionary. So they're going to collect this from the website for the day, and they're going to paste it into their code. So we're going to go and do that now. So we are jumping over here, and we're going to collect this dictionary here. Copy and paste it. And we're going to call it cups. this is back to our workbook. We're up to here, find the full dictionary at the link, copy and paste it in, and we're going to, for fun, do some formatting. It's not essential. Format paragraph, like this. You can also keep it on one line if that makes it easier to read for you, if you don't want all this extra text. Doesn't really matter, whatever the kids want to do. So we've done that step. Okay, cool. The next part is about looking up different words. So we can do current word, and we want to look up. We're going to use the thing that we have put in for. Sorry, I've done this the wrong way around. We want to get the cups. We're going to look up the current word. Yes, and we're going to store it in a variable called next word options. This, and then we're going to print that out. So what we're going to get back is all the words that could possibly follow whatever the user put in. So print next word options. Yep. And we're going to run our code. And we're going to try it for a bunch of different things. So here we have I, and these are all the words that follow I. We'll do the same for A and do, and then the kids have to write them in here. So we know that they've played around with their dictionary and actually run their code. Now we're going to try doing it for something that's not in the dictionary. So we're going to do Tom. Tom is not a character in the story, so we get a key error. There's also some bonus activities along the way. And what these are about, if the kids are getting ahead in the class and some of the kids are still trying to get through the basics, the green parts, then we can put the kids who are going super speedy onto these purple ones, and that will slow them down before we get to the next lecture, so they have something to do and they're not trying to guess the next part without having seen the lecture. So this one here, super simple. We can take current word, and we get current word dot lower, and put C on that current, and we can run it again. Now we can do something like Sam, and Sam can be followed by Sam I am, or Sam and I. Yep, so now we can see it works for uppercase words as well, otherwise it wouldn't have worked and we would have got a key error like we did with the activity above. So moving on, we're now getting rid of the problem where we have the key error by using if statements. So we go to our next lecture, if statements, and we're talking about metaphors that they already know, how if they do something then they get a reward, and things like that in life, and how we make decisions based on if something is happening, we do something else. Like if it's raining, we take an umbrella. And how these all work is with Booleans, which is a concept we're introducing here. So if something is true, we get to do something. If something is false, we don't get to do something. We have a few different things for them to play around with and to test out those Booleans. We can get, 5 is less than 10. See what happens. Dog equals dog. That's false. Yep, and we've got some more complicated ones on the next page. So these ones are important because we'll be using in for our Markov chains. So we'll be checking if a word that they want to start with is in the dictionary, so we don't look it up and then it's not there, basically. So we've got some simple ones like A in A, E, I, O, U, A in A, E, I, O, U. And then we've got ones with lists, and we've got ones with dictionaries, most importantly. So we've got phone book, everyone can have short names, and can be 111, then 222. Yeah. Phone book, I can look up, and we can try looking up someone who's not in the phone book. Cat. Cat is not in the phone book. Oops, I should have been trying with in, sorry. Okay, so we don't want to get the key error, so we have a phone book here, and then we can say, and in phone book, we get true. Or if we do cat in phone book, we get false. Do we use for later for our if statements? Okay, so we've got all the answers there. We point out that it only works if we're checking keys here as well. So we can't check out if 111 in phone book, because that's looking up something backwards, and we don't do that. When we look up things, one directional. So if we find out something is true, then we can make a decision based on that, and we have our code indented block, so basically anything underneath it that's indented, that will happen if that thing is true. So we have this here, we take this bit, we assess whether that's true or not. If it's true, we replace it with true. If true, do the thing. And then we see something happens. And we repeat that again for different numbers. And we can see how this is a control structure. If this is true, these things below it happen. So these are all part of this block. If they weren't indented, they wouldn't be part of the block. And they wouldn't be associated with the if statement. We've got all the important parts to note. If, indentation, colon, stuff to do, condition, the thing that gets evaluated to true or false. And now we're having another example, and we can see also we might want to do something if that wasn't the case. So we've introduced the else statement, and we can have something happen in all other circumstances. So we can see that, we've seen that GPN wasn't word and something happened, but we might want more options. We're also introducing elif. We don't actually need elif for this project unless they figure out a way to put it in themselves, but just, fun and learning stuff, we will put it in. They can have as many elifs as they want. So what are we doing here? We're going to be getting the kids to open a new file. We're copying this in, and really they just have to add a print, take an umbrella inside this section here and make sure it's indented so it happens only when it is raining, when the user enters raining. And a bonus to add an else statement for any of the kids who are super speedy again. So now we're up to the next part of the project, back to our workbooks. I don't know that word is what this is about. So we've got, we have to check if the word is in the dictionary before we start trying to assign next word options to that word's corresponding values, because there won't be any if they don't exist. So we're doing if current word in cups, what we call our dictionary, after our cup game, then we want to do assign the value and print it out. So give that a go. We want to start with an easy one. Start with I. Notice that everything's lowercase in our dictionary as well. And cool, we've got all our options. Let's try it again with something that's not in there, like Tom. And it doesn't do anything except print the first word as we had told it to do earlier, but it doesn't get a key error. So we actually have a bonus activity here to get them to print something out if it's not in there. So that's just adding an else statement. Else print. I don't know that word, or let's go with that because it's shorter. Yep. Now if I print, now if I go with Tom, it doesn't know what that is. Cool. So they will also have to remove their practice print in that step there. We'll get rid of that. So now we don't have extra prints randomly throughout our thing, and it works and it runs without giving us any errors. Okay, we're up to the next lecture again, which is over here. And it's on random. It's a really, really miniature lecture, and stream coordinators, if you didn't already know, you're giving this lecture because it's so small that I don't need to assign anybody to it except you. So this is about choosing something randomly from a list. Essentially, we need to draw something randomly from a hat is the metaphor we're using. So to do something like this, we need to import random. We're going to do this in the terminal because it'll be fun. And we get our shopping list. equal to, oops, eggs, milk, bread. That's fine. That's good enough for us. And we can do shopping. We're going to do random.choice. So we're choosing something randomly from the provided list. We'll do it again. We get something different every time. Well, not every time. Lots of bread. Yeah, let's go. And we've got everything in there. Awesome. So we can also assign whatever we choose randomly to a variable. Let's call it dinner. And we can print dinner out. Print dinner. Yep. So we can have a quick look at what this is actually doing. We're choosing something randomly from the list. But it's pretty self-explanatory. And now they're ready to do the next part of the book again. Okay, back to our book. We're now making choices for our random words. So we've got to go back to the top of the file. We're going to import random. We're going to go down, so that's 5.1 done. 5.2, we are going to randomly choose a next word. Random choice. And we're going to choose from our next word options. And then we're going to print it out. Print out the next word. And we'll remember that we want to make sure it doesn't go down a line, so we're going to use our end width. End. I'm going to set it to space. Okay, cool. Good to go. We'll run this. Let's start with a mouse. Awesome. So now we have chosen a next random word. We can do it again. Let's start A again. Another mouse. I believe there will be more words. A fox. Excellent. So we can see we're choosing a random word. Great. And here we have an activity where they go through A and they keep running it a few different times to get some different words out. So we've randomly chosen a word. We've seen different words that come after A. Done that part. Excellent. So now we're up to the part where we're going to need some for loops. So we're back to our lectures. So this is about looping through lists. So we've got a bunch of words. We could do it the boring way by indexing every single item, but that gets very boring very fast if you have a lot of items. You can relate to things to real life. You know, we just do the same thing over and over again for every page of a book or every fry in a packet. So we can see how Python is really good at looping through numbers. We can just say for blah in something, it will basically cut it up and will give us one of them at a time assigned to this variable. So we can print them out one at a time and have had access to them. So we've got another activity where we're getting them to do it in a new file. I'm going to skip that because every time I open a new file, it crashes my computer. Yeah, we could do it in this browser here. So, fruit is apple, banana, and mango for fruit in fruits. You can remind them that it doesn't actually matter what you call this variable here. It's just whatever you want it to be. And then we can just print tummy plus fruit. There we go. Yay! Okay, should have put a space in here, but I'm not going to. You get the idea. Okay, cool. So we also can generate a list in Python. What this is actually doing is generating an iterator. But we're not going to teach them about iterators. Iterators, if you haven't heard of those, they're kind of like a list that gets generated on the fly. But we can turn it into a list using a list and then putting it around an iterator so we can actually see it, because you can't see the whole iterator at once, actually. So let's try doing that. We're going to have list, range, 50. Oops. Cool. It's generated us 50 numbers starting from 0 going up to 49. So we could do 4 I in range 50 print I. Let's go. Woo. Okay, cool. So we can use that in our code shortly to basically decide how many words we want to generate in our chain. So we're now up to the part again where we're back to the workbook. We're getting towards the end of our beginner's workbook. Okay, cool. So we want to do this getting a new word 100 times. Yay! So we are going to take all of this code and we're going to put it inside, including our if. We're going to put it inside a for loop so we're going to start with for I in range 100. We're going to do 100 words and we're going to indent all of this inside so it happens 100 times. So every time we want to check if the word is in the dictionary, and then if it is, do the cool cup drawing thing. Yep. Okay, sweet. Now we get to run it and see what happens. We're going to start with A. House, house, fox, mouse, house, house. So we'll notice that these are all the same kinds of words, and that's because we never actually updated what the next word was going to be. So we never move on, we just keep randomly selecting from the words that would come after A. So we've got a similar example with I in the workbook. Let's give that a look. So you can see the words that come after I are am, do, would, do, yeah, that's for all of them. So that's why we only ever get those words. So we can see that we need to update what the current word is so we can look into the next cup along the chain. So all this means is we need to do current word equals next word. Save that and run that, and I hope we have a Markov chain generator. Let's start with the word I do not like them here or there. I am Sam. I do not in a fox. Not like them. Sam, I am. Would not like them in a mouse. Yep, looks like a Markov chain generator to me. Yay! So at this point, we've got a few different options depending on what room you're in and how late in the day it is. So if you've got to here and the kids and you've got heaps of time left in the day, then the next thing you'll move on to is the intermediate workbook, which means generating your own dictionary, your own cups dictionary from various other texts. So the girls will get more chances to have individuality and creativity over it. If it's later in the day but you've still got a bit of time and you want to challenge, for the girls they could do a trigram generator. So there'll be an extension for the beginners to do that. And what a trigram is like, if you're unfamiliar with the term, what we've just used is a bigram generator. So I goes to am, or pairs like that. Basically, I goes to do, etc. But for a trigram generator, for green eggs and ham, it might be I am goes to Sam. So we have two words link us to the third word. So there's an extension for the beginners that is about that. So we'll give them a trigram dictionary. So pairs of words will go to the next word and they need to work out how to update their existing code to make that work. But if you've got heaps of time left, we'll do the intermediate workbook. So we'll move over to that now. So now we'll take a look at the intermediate project then. So we've got our intermediate workbook and it builds on top of our beginner's workbook. So we're going to start by going to check out our website. So we've come off our main page into workbook 2 and we're going to have a bunch of new text. So we're going to now be working off strings to turn them into dictionaries, and later we'll get up to files and turning those into strings, which we can then turn into dictionaries. So basically giving the girls a lot more freedom in what text they can use. I should also note that for the beginners who don't get to do this activity, we'll provide them with a bunch more dictionaries at the end of the day so they can try different things out. So we now look into our intermediate workbook and we see we need to have our existing file from before. And the aim of this activity is we're going to make our own cups dictionary. So we're going to start by commenting that out. And we're actually also going to comment out all our other generated text as well at the moment, because that'll just be distracting and we won't have any cups to generate from for a little while. So we're going to get rid of all of this, commenting it out. Okay, cool. So we're now ready to put in some more space where we're going to generate our new cups dictionary. So we're going to start by making a new empty dictionary called cups, and we have lots of space around it. Excellent. Now we will go grab ourselves one of these cool strings. So this one here is just some Shakespearean sonnets, so I'm going to grab, and we're going to chuck it in a string. Kids might decide to grab some stuff off the internet that's multi-line stuff, so we can show them how to do that as well. So we have our source text, which will, if we want to do something multi-line, we'll be adding these triple quotes in. It might be something like this. But our texts that are actually on the side are actually just single liners, really long ones. So we're going to keep it like this just so I can fit more stuff on the screen. So get our source text. And now we need to turn that source text into a list of words. So we've got one big blob of characters at the moment and we want to split that up into individual words. So we're going to use the dot split method on our string to do that, and we're going to assign that to split text, which is in here. Split text equals source text dot split. And what this does is it takes a string and it splits it based on, automatically it will do it based on spaces, but if we wanted to split by something else like a comma, we could put a comma in here and it would change what the default was. So we're splitting the text up into a list. We can check that out. Print split text. And we can see we have a list that looks like the thing we put in. Nice and Shakespearean. Yep, cool. So we now have to go to the next part, which is we want to get the length of the text that we've just generated, this list we've just generated. So let's get rid of that print. It's just a long print we don't need. And we can have like len text equals len of split text. Let's print that out. So we've got 346 words in our split text. Cool. We can get rid of that one as well. And watch out if the girls might do print the length of the source text, in which case you'll have a lot more words. Okay, cool. We can check through all of these boxes, put the text in a variable, split it into a list, got the length of the list. Now we can iterate through this list, and we're going to put it into our dictionary shortly. But first, we're just building up to that, iterating through our list. So we are, like we did for the generator part, we are going to go using a for loop and range. This time our for loop doesn't go for a random number we just chose, which was 100. We want to do it for the length of the text. So we're going to do for I or num in range, and we're going to do it for len text. And we're just going to start by printing out num. Let's go. And it's going to go for a while, but it looks good to me. Excellent. Okay, cool. So the next thing we're going to be doing while that finishes off is we want to now be assigning the current word. So the word we're currently up to. So we want to go through the words one at a time, and shortly we'll need that to put it in the dictionary, but for now we're just going to print it out. So we're going to say current word, and we're going to index the list. So split text, and we're going to use num to get that position, and we can print that out too, which will be nice and slow too. I'll just cut that off here. Control C. There we go. Okay, cool. That gives us all the words. Awesome. Printed it out. Great. Now we want to do the same thing for next word, because we always need to look one word ahead in our dictionary, in our list, to grab the things, the pairs for the dictionary, key and value. So we're also going to assign, we'll get rid of this print. I'm going to assign next word equals split text num plus 1. Okay, cool. And then we will print this one out. Actually, we know what it looks like. It'll slow us down. But we do want to get to the end and see this list index out of range. So what's happened here is we've said go through all the words and look at that current word and the word after it. And we get to a problem when we get to the end of the list where we try to look at the word that's after the last word in the list. So we've got a little picture here to help them with this. And we can see that we've gone all the way through this list looking at pairs. And when we get up to the last word, we try to look at the one after it. So what we need to do here to fix this problem is we need to look only up to the second last word for pairs. So we've just changed this len text to len text -1, and we can run that again, and it's all fine. Cool. So now we are up to the part where we get to put it into dictionaries. So we've already got our empty cups dictionary, and we are going to start by just doing a basic thing where we're going to say cups, and we have our word, which is our current word, and we're going to set it to be next word. And then we're going to, at the end, print out cups. Let's give that a go. So we can see in here that this isn't like the dictionary we had before. We don't have a list of values after everything. So that's a bit of a problem. When we try to choose randomly, we're only actually ever going to have one option, which wouldn't be very fun. So we need to actually build a list in there, one item at a time. So we can see, we know here that we're always only going to have the last option that was added because we've been overriding it all the time. And you can't have duplicate keys in a dictionary, so that's how that works. So let's go to 3.2, and we're going to get rid of this code here, cups. And we're going to say, we're going to use an if statement. So we check if current word not in. So we're starting with the case where it's not already in there, because we're going to need to add a list. In this case, we're going to say cups, and then we're going to have the current word equal to, and then we're going to have a list, and we're just going to put in the one word we have, which is the next word. Okay, cool. And then our other option, else, it's not in there, or if it is in there, sorry, if we had not in, so it might be slightly confused on because they've only done in so far, but they deserve a challenge. If it is in there, we're going to have cups current word, and this time we're going to add to the dictionary. I should have gone through. We've got some more slides for these actually. So we've got more of the appending. So we actually did this earlier, and we are now looking at how to make our own dictionary. So we've got our empty dictionary, and we're showing how to add something to the dictionary. So we can say set Jeanette to 99 for our phone book. We can add some more phone numbers, and then we have a similar thing to what we had before, where we're now building lists. So we can set our team, if we have an empty dictionary for team members, we set a team name and we give it an empty list of players. Then we can start appending names to that list using this code here. So we're going to do the same thing over here. So we're going to have cops current word, and then we're going to append the next word. And we have a little bit on how that works here. So the girls might notice that how we possibly appending to something, doesn't this make a copy of something? Because we have actually previously, when we made copies of X and Y right at the start, when we did variables, it made a copy. So when you changed X, Y wasn't the same if you'd already set it to X. So this one doesn't make a copy. This is actually just a pointer to that location, and it appends to that list. But that's kind of only if they're done a bunch of stuff before, might they notice that. So this looks good. This is the corresponding part of the workbook that we've already been working through. And here we go. And we have added our next word. That looks promising. Let's print that out. Print cups. And we'll have some words. Do we have? Yes, we have some that have multiple things in them. Excellent. Okay, cool. So, looks like we've done that part. We have a dictionary and list possible words for each word. And we've printed it out to make sure it looks the same. Now we can get rid of that print as well. Okay, so now we can uncomment our code from the bottom here. Get rid of that. Excellent. And we'll get rid of these comments as well, so we can have some input as well. Let's try it out. So we will start with sweet. Oops. Oh dear. That's a bad option. That was probably the last word in the dictionary. Who knows? Skill. That looks like it's the last word in the dictionary. Let's try it again with a nice regular word like you. Beautiful. Date sometimes declines by chance or nature's changing course. Untrimmed but thy ere imperfect shade, when most I compare thee in eternal lines, etc., etc. Great. So we have now generated our own cups dictionary, and we have made some crazy text out of it. So the girls will have a bunch of text they can do if they want to keep playing with that. If you don't have much time in the day, let them play with some text. Maybe put two different texts together. Just concatenate a Harry Potter text to a Shakespeare text and see what happens. But if you have a bunch more time left in the day, we have a few options as well. So we have some extensions. This one looks at using files to get text out of, so they don't have to have these big lines of text copy and pasted it into their document. And we also have another extension, which is a trigram extension, like I described for the beginners, but also generating our own text, our own cups dictionary for it. I'll quickly show you what the files one would look like. So what this is, we will be getting rid of this line here, and we'll be bringing our own string to the party from our file. I won't grab us the file and make us do it completely. I'll just show you what it would look like, because it's pretty fast. So we would be saying our file F, we'll assign this object, our file object that is open, to F, and we'll be saying open, and then we will make sure they have a file. We could call it, you know, source, or let's call it Harry Potter or something. Potter.txt. And they need to have that in the same directory, in the same folder as their code. And then to grab the text out, we can just go text inside Harry, and then we can do f.read. So that just says get the file object you just opened and read it. Yep, and that would create us a text that we can grab out, which is pretty cool. If they're just randomly grabbing text from the internet, they might encounter some, you know, messy problems that it's got a bunch of spaces, like new line, characters, enters, punctuation and capitalization. So we've tried to strip that out of the ones we're providing to them. So if they want to clean up their text, they can do a few things. So we can see in here we're talking about removing these different pieces with replace. So we could say, you know, text inside Harry equal to text inside Harry dot replace, and we might want to just replace all the question marks with the empty string, or you might want to replace all the enters, which is, if you haven't done it before, \n, and then we might want to replace them with spaces instead of having new lines everywhere. So that's how we would do our files extensions. Yeah, so that pretty much brings us to the end of that. We do have some slides on files in here as well if the kids do want to go through them. And that's all our slides for beginners and intermediate. Yeah, hope that is helpful. As always, let me know if you have questions. And yeah, I hope you didn't notice too much how my windows kept moving around. My idle liked to crash a lot during this production. Thanks for watching, yeah, and see you at the workshop or some other time.